So with that, I think we have a little bit of time to engage in our normal exercise. Only 20 minutes, so I'll only be able to do one or two questions. But let me do this problem solving with the ChatGPT exercise. This is where I'm actually encouraging you to use generative AI. Use it to learn, not to, cut corners. So let me get started. Since we don't have a lot of time, let me kind of be efficient in how I go about it. So let me get to the problem set that I'll be working through. That's the problem set this week, problem set 6, the one that's due on Monday. And since I've been, so 4.5 is available, but since we've been using O1, let me just continue using O1. I do want to come back to 4.5 with drawing free body diagrams, because I do know that's the one task that ChatGPT O1 can't do. So I do think it'll be worthwhile to see if the newest version of ChatGPT model can actually draw free body diagrams in a way that's helpful to you. I'm interested. So, all right, problem set 6, due on March 10th. That's what I'm working on. And we probably have enough time for 2 questions, maybe 3 if they are easy questions and I don't make too many mistakes. So as you are working on it, now this is my recommendation to you. You can't simply copy and paste your question into ChatGPT, because if you do that, it'll do the thing that you've seen it do because of its training bias. It's really trained to give you full answer right away without a lot of false friction, with the holding answer. It'll just tell you the answer. So if you do that, then unless you mistook that comma for period, you can do this and it won't help you learn. So what you really need to do is you have to ask it to teach you how to do these questions. So sorry, I meant to tell you first. I'm working through these problem sets as a practice for my later one-on-one meeting with my instructor, and I can't use any outside resource at that meeting. He said I can maybe use the textbook with a time limit. So I really need to learn how to do these questions myself. So for the um, for the um, um, for the future questions, please don't solve them for me. Maybe give me a really small hint and ask me what I have done so that I can explain my thought process and have your help in working through places where I got stuck. Please. And it'll acknowledge. Ooh, let me find the question that so on our YouTube channel there's the most popular video that's there that I'm pretty sure is popular because somebody linked from outside, and also it's a deceptively difficult question. Let me see. I've gotten the question here. If I have, I will use that as our first question to work through, just because it's a fun question. I don't see it. Yeah, I don't think it's in the set I've gotten. So it's probably in this group. So what I'm gonna do is I'm gonna get a similar question. Then there's a chance. Okay, this is not the question that I'm looking for. Oh wait, is it? Oh yeah. I think this is the question. Yeah. It's a it appears simple, and I don't know if a hint helps you that much. Yeah. So hint one actually kind of helps you. So looking at it, you might think, all right, that looks simple enough. I read the textbook. I know I remember the definition of work. So work is defined as the dot product between force and displacement. So F delta x cosine theta. So you think, okay, calculate the work of the applied force, you say applied force times I have delta x, I have theta. Great. So let's say, and then you should realize, oh, I don't know F. So for the work of the applied force, as you are trying to apply the definition, you should realize that they didn't give you the applied force. Now, I've seen students try this. Sometimes the student will guess. The only other force that's here is going to come from this. So maybe F is equal to mg. So you do mg delta x cosine theta. Plug in the numbers. Let me actually plug in the actual numbers with the calculator. So you do 37 times g 9.8 times delta x 11 times angle 50 degrees cosine of is equal to 2564 joule. 2564 joule. And you definitely should get the answer that it's wrong. I did fix up this question in the last semester version. There was a very tiny chance that these random numbers generate in such a way. There was a small chance that this expression could still give you the correct answer. But I've rewritten the question so that should not happen, so that people are not misled into thinking that this definitely incorrect approach is somehow correct. So. So let's say you got stuck here. I think that's a quite common place where students do get stuck. And I'm pretty sure that's the reason why that particular video working this out is popular on our channel. So hint one actually does help you because you do need to figure out what the applied force is first. You can't just say F is equal to mg. That's wrong. You have to use a standard strategy. You need to figure out the force. But let's say reading this hint, you don't realize that's what you need to do. And reading this hint, that's a hint for parts B and C. There is a shortcut, but you need to get part A first. So let me ask ChatGPT. I thought this was an easy application of definition of work, but the system tells me I'm wrong. Can you help me write an errata report for my instructor? I'm just, trying to see if ChatGPT will agree with me. In the past, it hasn't. When I wrongly implied there's an error in the question, it has correctly told me that there isn't an error in the question. Oh, wait, maybe they'll focusing on what went wrong in your original approach. Yeah, there's no error in the question. So really, what you should have corrected, originally assumed that the pulling force is that. No, but it's not a correction. It's at least not a correction to the question. It's correction to your solution. And if you're writing this to me, I guess I'll read it first, and then I'll say, okay, I'm glad to see you've corrected your solution. Thank you for sharing your corrected solution, and I'll probably stop there. I won't yell at you. The force doing the pulling is not simply mg. Yeah, the friction force depends on normal force, right, which is reduced by vertical component of the pulling force. Because the sled moves at a constant velocity, this is actually an important part. This information is not directly given to you in the question. So you have to read the question carefully and figure out constant velocity means zero acceleration, and zero acceleration means zero net force. That's a important key information that you have to figure out from reading the question carefully, which means the horizontal component must exactly balance the friction, which is that. In other words, I confused the way. Okay, you can then discuss. Oh, so I'll say, you mean I made a mistake, just to clarify. By the way, ChatGPT will always be very polite to you. So this very polite response, don't mistake it as you not having made a mistake. Yeah. On the right hand of this, something is off. Yeah. But another way of saying polite is to be very roundabout. So you have to be the direct one. So hope if as you are reading this, you figured out this, then I think that might be good. And in the interest of time, let me not play dumb and kind of work through. So I think I can start with the 3 here. So say the net horizontal force is 0. So okay, let me write that down. So net horizontal force, net force in the x direction is equal to the friction force mu k times adjusted normal force. Okay, mu k times normal force. Let me follow ChatGPT's approach, which is not to write down the net force. Having figured out it's 0, it's just saying the applied force in the x component is that. Saying that, okay, the friction force depends on normal force, which is reduced by vertical component of the pulling force. Okay. So what you would end up writing down is normal force is equal to mg minus vertical component of applied force. Let's say you don't immediately go from this English sentence into this mathematical expression. Then you can ask ChatGPT. So, I can say, okay, for about that, okay, I think I got number 3. See screenshot. But I'm not sure what you mean by this. Can you explain? Then ChatGPT will give you the next step. Maybe even give you this mathematical expression. Yeah. So that's it. So let me write it down. To write down the combined version, so plugging in normal force, I have F applied in the x direction is equal to mu k times mg minus F applied in the y direction. Okay. Let me see if ChatGPT gave me further hint that should help me with this. Because, yeah. So I'll say, okay, I got this so far. But I don't know what to solve for. What you have to do is you have to rewrite this in terms of the magnitude f. Oh, not that. Let me erase that. Magnitude f and the angle theta. Because right now you have basically form of one equation, 2 unknowns, x component, y component, but you know the angle. You have to make use of that fact. So yeah, ChatGPT will tell you all that. Make use of that fact. Then expressing if you can solve for it. Yeah, that's it. So let's do that. I think we only have 5 minutes left, so let me not waste too much more time. So I will plug in f cos theta is equal to mu k mg. I'm separating these out, minus mu k f sine theta, and doing the algebra in my head, which is a bad habit. You should really writing things down. It helps you develop your algebra skill. And once you've built up your algebra skill, then you can still have a bad habit and have a correct answer. So doing my bad habit way, f applied is equal to mu k mg divided by cosine theta plus mu k sine theta. So from here, I can plug in the number, and I'll have ChatGPT check my answer, check my numerical answer. Well, I'll get f applied first to calculate the work. Or actually, let me have ChatGPT check my applied work. So, with my calculator, my friction coefficient is 0.11 times the mass, 37 times g, 9.8, divided by parenthesis open, cosine of 50 degrees, plus mu k, so 0.11 times cosine of 50 degrees. Oops, not cosine, sine of 50 degrees. Ooh, I hate this. This is why I gotta retype everything. This is why I normally prefer Wolfram Alpha. It's a lot easier to correct when you make simple typo like that. Okay, cosine, okay, plus mu k times the sine of 50. All right, so that should be equal to 54.86 newtons. So I'll say I get 54.86 newtons. Is that correct? I don't want to waste another attempt in the system. Which is ironic because I'm wasting my O1 response doing this, where here's like I got 100 attempts. There's no wasting one of my 100 attempts. On the right track. So in that range should be the correct pulling force. Yeah, and whether that. Oh yeah, I mean, this is good advice. I mean, what if in the future you don't have access to ChatGPT, like in our one-on-one meeting? Sanity check is a really good habit to get into. So is it bigger than it would be if you weren't pulling upward? Well, I don't know if that's a good check. I think there's an angle at which it would. Or it's yeah. So it would be. I'm not sure. I'm not sure if this is the check I would do. Let me move on. And it says it sounds correct, so I'm going to assume it's correct. And take that expression. Where is it? Well, not that. All right. Okay. Take that expression. Multiply that to cosine 50 degrees. That's force times cosine theta times, now I need a delta x, 11 times 11. So I get 387.9 joule. Yeah. So I'll say, okay, I got it right. And then I'll say I'll ask about the hint. Maybe you don't know what the hint is about. So I'll say, okay, I got it right. Hint 2 says that there is a shortcut for answering B and C once I have A. Can you tell me what that shortcut might be? That shortcut relies on the fact that C is actually 0, work kinetic energy theorem. And once you know that, then you automatically know that work done to friction must exactly balance out work done by applied force. That should be ChatGPT's answer. Let's see if it gives you that answer. And the trick is, yeah, it's not accelerating, so its network is 0 from work kinetic energy theorem. Yeah, so, yeah, that's exactly right. Yeah. So I'll say thank you, and it looks like we are out of time. So, right. All right. Thank you. I have to go. And that's it for this session. Sorry, I really overestimated how many questions we could do in 20 minutes. But, when this is one of the benefits of having ChatGPT as a virtual tutor as you're working on it. Like, you don't have that kind of arbitrary time limit. You might have a limit to how many O1 responses you have and all that, but that's a different question altogether. So all right, that's it for this demo. Thank you to everyone joining this virtual class session, both here in real time and those who may be joining by recorded video. Let me say goodbye to people joining by recorded video, by which I mean I'm gonna stop the recording, and let me stay online briefly for the people who are here in real time in case they have a question. So bye to people joining by recorded video.